Hello, and welcome to Focused Wherever. In this garage series video, I'm going to try to fix the biggest problem with my garage, the heat and humidity. If you watch my garage introduction video, I've got a lot of projects planned, but I want to be comfortable while doing them. To do that, I'm going to add a portable air conditioner to this space that has no windows and no side door. So with that as the goal, let's get focused. So here is the problem. At 11 a.m. it is 86 degrees inside the garage. If I check some surfaces, nearly 88 degrees, and the heat radiating off of the garage door, 102 degrees. It's also quite humid in here. Outside currently, the humidity is about 75%. It's more or less the same inside the garage. If I open the garage doors in hopes of getting some breeze, even both of them, it just doesn't come through in any kind of way to make it more comfortable in here. So in order to make it more bearable to do some of the projects I have planned this summer, I've got to come up with a solution. And this is what I'm going to try. The Hisense 700 square foot portable air conditioning unit. My garage is about 33 by 20, which is 660 square feet within the range stated for that unit. But it's got a few things working against it. Gaps around the garage doors, lack of insulation on the garage doors, and my ceilings are 10 feet, so it's got some cubic footage that's got to handle. It's not my expectation that this is going to get the temperature down to 72 degrees. My hopes is that it can get it maybe somewhere into the 70s and just make it quite a bit more comfortable to work inside the garage. So let's get started. Here's everything unboxed. The AC unit itself. This is a dual hose model, so the two hoses are here, and each hose gets a coupling to attach it to the back of the air conditioner, and the outlet coupling that fastens it to the window panel. In my case, I'll be putting this underneath the garage door as opposed to a window. Don't have a window in the garage. The panel width, the outlet panel width, is not as wide as at its maximum width, not as wide as the width of my garage door, so I'll be developing a solution to block the rest of the underside of the garage door. It includes foam to surround the outlet panel, your paperwork, manuals, warranty type things, a remote control with batteries included, a drain hose, and some hardware primarily for securing your window, as it won't be locking. If you're using it in a window, it won't be able to lock, being that it's lifted. So they give you some brackets and screws to secure your window, since it won't be down and locked. A few things about the unit itself. It is a 115 volt, 60 hertz, 12 amp unit that includes a timer. It has a removable washable filter. The temperature range through the thermostat control is 61 to 86 degrees Fahrenheit. 3 fan speeds. It's about 80 pounds, so it's not the easiest thing to lift, but it is on wheels, which seem to move it around pretty well. It's a 10,000 BTU unit. It can dehumidify the air at 3.3 pints per hour. And again, this is a 700 square foot coverage. Parts and labor warranty, 2 years. And the sound level, the noise level in dBAs, decibels, is 50 to 53. This model includes a heat pump, but altogether it has 4 different modes: cooling mode, dehumidify, heat, and fan. All right, the AC is all set up and ready for its test run. So it appears that everything on the primary control panel is available on the remote as well. So the target temperature is 74 degrees and it's currently 88 degrees. Pretty close match on that reading. Right now I don't have it venting outside. That's the second half of the project, to fit it to go under the garage door. Relatively quiet. I sense that most of the noise that I hear is actually coming from the exhaust, so once that's pointed outside, that should reduce the noise quite a bit. The drain hose is not needed under normal operation. This is a waterless system, so it doesn't require continuous draining. There's a note in there about an error message that may come up if it's got too much water in it, and then in that case there is a drain. But under normal operation, that drain plug and the drain hose are not needed. So now we got to get it set up to where it blows outside. We'll take a few measurements and then head off to the store to get the supplies needed to get that done. So the primary panel included with the AC unit is 24.5 inches wide. And to get it to go out underneath my garage, I've got to span a bigger opening than that. That opening is 98.5 inches, 95 showing on the tape, plus 3.5 for the tape measure body, 98.5 inches. Where the door will come down and rest on this barrier will go right into that notch there. And the door will come right down on top of it. So 98.5 is the opening, 24.5 is the plate. There are additional plates in the kit. I decided not to use those since I'm having to supplement it anyway. I'll just use a single piece to go with this one primary panel. So 98 total minus 98.5 total minus the 24.5. I've got to find a solution to bridge 74 inches of space underneath the door. This panel without the foam is about 5 3/4 inch tall, so maybe right around 6 inches with the panel and the foam slightly compressed. So my plan is to use a 2x6, and I may have to put some sort of additional furring strip or some sort of foam on top of it to get it to be as close to that 5 3/4 to 6 inch range as possible, as a 2x6 will be 5.5 inches. So I'll have to raise that 2x6 just a bit. Here's what I've come up with to fill in the rest of the space underneath the garage door. I purchased 4 2x4s and cut them and assembled them to create the rest of the barrier. I went with pressure treated because this will be exposed to rain and moisture from the outside. At each end, I've cut a notch so that it'll fit between the track and the wall. Same on this side. I've attached each of the boards to each other using waterproof glue, wood glue, and decking screws, so it's quite secure. And then where each end meets the exhaust plate, I built a little bracket that helps it stand upright. These are removable. I also found that a couple 2x4s underneath the hoses helps keep that plate upright as well. The total height of my 4 stacked 2x4s is just below the height of the plate plus the foam, maybe about an 1/8 of an inch lower. But that's a perfect height because when the door comes down and rests on this or makes contact with this foam, it'll compress the foam and then actually be resting. All the weight will be on the boards themselves and not on this plastic plate. I decided to put a little piece of wood here, a section at the right end, so that the weight of the door is on the wood at both sides. My door does have a spring on it, so it's pretty weight neutral in about any position, but I didn't want it resting on the plastic. So like I said, once the foam is compressed, whatever weight there is, it'll actually be in contact with the wood itself. So that'll cover the bottom gap. The door will not be, of course, closed entirely, which will leave a gap at the top. So my plan for that is to cover it with a canvas and poly drop cloth. I got a 4x15, which will span that. I'm basically going to kind of tuck it in there, and on the sides just kind of fill in the gaps as best I can. Certainly not airtight, but it'll prevent flow of air, significant flow of air, from coming right back in through the top of the door. So that's the plan for the top and the bottom, to close them up as much as possible. So now I'm going to put everything in place and get ready to cool the garage down. A quick checkpoint with the bottom in place from the outside. Everything's looking pretty good. It's sitting nicely, the door sitting nicely on the barrier. And likewise on the interior, a couple small gaps there. The pavers have tapered edges, not much I can do about that, but the door is sitting nicely on the inside on the wood and the foam. So a quick view of then what's left to fill in on the top. This is the gap that remains at the top. So I'll put the canvas drop cloth in there and see how I can fill that space. First attempt to block off the top with the canvas drop cloth is in place. A little bit rough, but it's filling the space reasonably well. I think in future installations I may try to roll that canvas up and tuck it in there a little bit better, but it is sealing the space reasonably well on this first attempt. The reason I went with the canvas drop cloth versus plastic or tape was so that it's repeatable without consuming a lot of material. However, I did use some masking tape to close off this gap in the door with it not being all the way down. And here's a look at how I tucked it in along the gap that exists along the side. Again, I think maybe rolling it up on the next attempt just might make it a little easier to get it even. In terms of how I've lowered the door down, I've disconnected it from the opener and just manually lowered it down onto the bottom support. So everything's sealed up as best I can for this first attempt, and we're ready to start cooling things down. All right, I'm gonna start up the air conditioner and set a timer for 15-minute intervals. Check it every 15 minutes for an hour and see what kind of progress we make. So let's get it going. So a target temperature of 75 degrees, currently 88 degrees in the garage. And we will start the timer. First 15-minute checkpoint. When I started 15 minutes ago, I noticed the room temperature indication was jumping between 86 and 88, so we'll call it 87 as a starting point. 15 minutes in, we're holding at 84. It certainly is blowing nice cool air out. It was my original expectation that it could take more than an hour easily to make significant progress, but in 15 minutes we've gained about 3 degrees, so check back in another 15. Second 15-minute checkpoint, so a total of 30 minutes of cooling time so far. We've gained another 2 degrees, now down to 82, and for the first time I do sense that it's significantly less humid in the garage, so we're making good progress. We'll check back in another 15 minutes. 45 minutes of total runtime now. We're still at 82 degrees, so we've gained 5 degrees in 45 minutes. But I will say I still sense a continued improvement in the humidity in the garage, so check back in another 15 minutes, see how we're doing. A full hour of cooling now, and we're still at 82 degrees, so don't know if that's an indication of that's the best that it's going to do. Certainly a big improvement over where it started, not only in the 5 degrees that we've gained in that hour, but a significant improvement in the air quality in here, a lot less humid. It's a pretty challenging day for this first run. It's 90 degrees out, 94 degree heat index, 70% humidity. So we've made some progress. I'm going to let it run for another hour, check back in an hour and see if it can gain any more. So the AC has been running for 2 full hours now. We did manage to gain 1 more degree. So in that 2 hours we've gone from 87 to 81. Definitely a significant improvement in the overall feel of the air in here. Takes some time to pull the humidity out of the air, and even versus an hour ago it feels less humid. So while the temperature's not changing much, it's just considerably more comfortable in terms of reduced humidity. So I'm going to end this first test now and do a couple other tests, one this evening once the heat of the day breaks and the garage temperature without the AC running is at a lower starting point. We'll run it again for an hour and see if it makes any faster progress. And then I'll also run a test tomorrow morning before the heat of the day starts to build and see if we get some air conditioning in the garage before the temperature starts to rise, if we can get to and maintain a lower temperature. But not bad for a first run. World's better than where we started. So we'll check back in later. Alright, final update on the garage AC project. I did run it again yesterday evening after the outside temperature had cooled down a little bit. So the garage started off at 84 degrees, and in 90 minutes it was able to cool down in here to 79 degrees. The humidity was actually up yesterday evening compared to the afternoon, so the outside humidity was 84%. So the air conditioner had to overcome that, but it did get it down to 79 degrees. And ran another test this morning before the heat of the day got going. At that point, the morning run, the starting temperature in the garage was 82 degrees. And then again, in 90 minutes, it was able to hit that same 79 degree mark. Still high humidity outside at that point, still in the 80% humidity range. So 79 degrees was the best it could do. For both those tests, the yesterday evening and this morning, I had taken this canvas drop cloth that I was using as the upper barrier and rolled it up and strapped it with some Velcro straps. That just wasn't getting it done. It just didn't look good. It wasn't really filling the gap uniformly. So this afternoon I switched over to a radiant barrier type foil that's held in place by Velcro. So I did the top, I did the sides with a custom cut piece, and then where I had masking tape across that one gap in the door, Velcro backing and cut to fit the space. I'll climb up on the ladder and see So a good snug fit across the top of the door, so quite a bit less airspace around that top barrier. So with that in place, the AC was able to gain 2 more degrees, 77. Outside conditions are pretty similar to where we were 24 hours ago, about 90 degrees and 80 or so % humidity. So I think that was a worthwhile improvement to switch to a better fit, better material, better fit. Here's a closer look at the foil barriers. The largest piece on the left goes across the top of the door. The 2 triangles cover the upper sides, and the 2 long skinny strips cover a gap in the face of the door itself. And this is a look at everything disassembled and ready to be stored. As a last step on this project, I painted the face of the outlet plate and all sides of the wooden barrier just to make them a little less noticeable from the outside. That's going to do it for this video. Overall, I would definitely call this a success. On a hot summer day, I was able to reduce the garage's temperature by 10 degrees and, more importantly, significantly reduce the humidity to the point where it's quite comfortable to work in there. If you have any thoughts on how to make it better, let me know in the comments. Thank you for watching. If you enjoyed this video, hit that thumbs up button and consider subscribing to find your way back for more garage adventures. Have a great day and always stay focused.